Right, now we are going to learn about vector geometry. From the title, you know that it has to do with vector plus geometry, which is about shapes. Now let's just look at this simple line. This is some basics that you need to know in order for you to master the topic on vector geometry. So the first thing we want to start by looking at ratio. So we have line PQR. You want to find the vector PR. So the number here shows the ratio of PQ to QR, which is 1 to 2. If the vector PQ is A, so we can use the ratio to help us in this. So the vector for QR is 2A. And now let's look at how we can write PR. Now PR can be written as PQ plus QR. So by just substituting this, we can get PR is 3A. Or we can just write PR is 3 times of PQ, which is 3A also. Alright. So the next thing, if we say something is the midpoint of a line, the ratio will be always 1 to 1. Alright. So the vector MN is also B here. So vector LN is 2 times of LM, so it's 2B. Okay, so let's look at some examples. So the first example here, we have a simple triangle with OA and OB, and we are asked to find vector AM, which is M is the midpoint of AB. So the first thing we need to find is vector AB. Alright, we can use this same method. AB is equals to OB minus OA. We substitute the vector inside. Rearrange it in the form of AB. And now we can say AM is half of AB because M is the midpoint. So by substituting AB here, you get AM is half of negative A plus B. Now one thing to note about vector geometry, we cannot use column vector because this has no x-axis and y-axis. Alright, so we keep in this form. Okay, the second example, we use an example from the CUP course book, question 1. So this is a more complicated example. So let's understand the diagram a little bit. They say R is the midpoint of OA. So the ratio here is 1 to 1. And OP is equals to 3OB. OB is 3OB. So the ratio here is 1 to 2. Okay. So identifying the ratio is the first thing. Now here we have two lines which will help us to answer the questions. Okay, so the first part of the question is finding OQ in terms of lambda, A, and B. So if we want to find using in terms of lambda, we use this equation. Okay, AQ equals to lambda AB. So we expand this vector using the position vectors. Alright, so now we just substitute the various position vector that we know, which is OA and OB, and then we expand this part and bring over the A, and the last part is factorizing the A, and we get the answer for OQ. Alright, for part B is asking for OQ in terms of mu, A and B. So when we see mu, we know that we have to use this equation. So using this equation, RQ equals to mu RP. So expand it, and we do the same by substituting the various position vector that we know. But before that, we need to substitute the relationship that we know from the ratio. So OR is actually half of OA, and then OP is 3OB. And now we can substitute the vector A and B, and we just do some simplification and also factorizing, and then we can get another form of vector OQ. Alright, the third one is the most common type of question, which is to solve what is lambda and mu. Since we have two different forms of OQ that we got just now, we can compare the vector A and as well as the vector B. So we will find ourselves to have two simultaneous equations which we need to solve it. So you have to do the simultaneous equation solving by yourself. So at the end, the answer is lambda is 305 and mu is 105.